So good afternoon. You're the hardcore crew staying for the last session of the day before the party. So for the next hour, we want to talk about troubleshooting Windows deployments. My name is Mike Niehaus. I'm product manager for Windows deployment from Redmond. How many of you have been in this session before? Because I've done this at previous TechEd events, and yet you come back again. I guess that's a good sign. It hasn't changed a whole lot. We'll change some, and we'll talk about some of the changes that have been made in subsequent releases of MDT to try to make some of these problems better. And we'll talk a little bit about the differences between Windows 7 and Windows 8. But for the most part, the troubleshooting process really hasn't changed. I mean, it's the same basic problems that you run into regardless of the version of Windows that you're deploying, which is a good thing. Of course, the bad thing is you still run into these types of problems. So we need to figure out how to troubleshoot these. We know that there are plenty of different ways to deploy Windows. We know that there are plenty of different tools that get tied together into this deployment process. There are many moving parts, so there are many places where it can fail. So we need to figure out how to troubleshoot each of those parts. So we'll talk some about each of those, kind of building up from those lower level tools provided as part of the Windows AIK or the ADK. Things like Windows PE, USMT, ImageX, those lower level pieces. Windows Deployment Services provides Pixie and Multicast as a layer sitting on top of those lower tools. And then you have MDT and Configuration Manager as deployment products or deployment solutions that tie all those together into a particular deployment process. This is what we typically get to, though. We get to the point where we see an error and we had to figure out what happened. Why did we get an error that says 80004005, and what the heck does that mean? Why did we have a machine reboot? Why did it crash? Why did it blue screen? How do we troubleshoot these when the error messages that you see on the screen are pretty much useless? There's no way you can look at these and actually see what happened, what broke. As much as we try to refine things, in the end it gets to the point where it just says, I broke. So we had to figure out how to troubleshoot that. As far as the Windows 8 processes and the changes to that, Windows 8 deploys just like Windows 7, which is great because that means it breaks the same way as Windows 7 and we troubleshoot it the same way as Windows 7. So we don't have to worry so much about changes that impact the deployment process related to Windows 8. Anything you learned about troubleshooting Windows 7 still applies for Windows 8 too. We'll talk more about Windows 8 tomorrow morning in the next session that I'm doing, WCL 306. So for today, when we're talking about Windows and troubleshooting and solving problems, assume that everything I say for Windows 7 also applies for Windows 8 or vice versa. So, how do we get to the root cause? Log files. Log files, log files, log files. I mean, anytime you run into a problem, you're going to see something on the screen, and that something on the screen isn't going to tell you what the real problem is. With rare exceptions where it clearly says this is what the problem is, most of the time you're going to have to go digging into the logs to figure out what happened. So it's useful to look at these logs routinely so that you know what normal looks like. What does a successful deployment look like? What messages are in a normal set of log files that might look like they're an error. But if the whole deployment process finished, it must not be an error because the whole process worked. So knowing what a good deployment looks like enables you to ignore the noise, to be able to look at things and say, yes, I've seen that before, that's not an issue, on to the next item. Because a lot of these log files really weren't written for IT pros to routinely be reading through them. I mean, in the case of MDT, the logs that we write out, we've tried to do our best to make them readable by you guys, the people that would be looking at them routinely. But for Config Manager, for WDS, for some of the other tools that are out there, these log files were written for the developers. The people that initially wrote the code, the people who get the escalations through the support channels to try to figure out what happened, they're not necessarily written for normal people. So, like if you were to look at a config manager log from a deployment task sequence, you're going to see errors all over the place. And they're all normal. They're not really errors. They're just distractions from actually troubleshooting what really happened. So we have to be able to figure out what's normal, what isn't normal. The other challenge is, in a lot of cases, you'll see that the errors are not in the logs. What you'll see is what's missing. You have to figure out what isn't in the logs to figure out what should have happened. In a lot of cases in MDT, we would be troubleshooting issues by going through a log file, and what we would expect to see next didn't show up. So we know at that point, here's where we went sideways. We don't necessarily know why. Now we can look at the scripts and try to figure that out. So we've made a conscious effort inside of MDT to say we need to go back through all of these, and any place where we think it would be useful to have another log entry, let's add some more logging. So that we don't get into this situation where we're trying to figure out what's missing from the logs as a way to troubleshoot what problem occurred. So we've gotten better with that, about that over time, but it's still not perfect. We still get into situations where, we just can't figure it out. Another key process, another key ability that you need to have is knowing how to translate error numbers into something useful. Unfortunately, the task sequencing engine itself isn't particularly good at that. We'll look at an example as we go through here, but there are cases where a process can exit with a particular return code that gets translated into an error that has nothing to do with the original problem. The text that it comes up with is just complete gibberish. The most recent one has been, I am getting a DNS node creation error when I'm doing my OS deployment. You're getting a what? What does DNS node creation have to do with OS deployment? Absolutely nothing, but the error number being reported back by one of the MDT scripts, if you ask Windows to translate it into generic error text, the error text is DNS node creation failed. So it's a distraction. It causes people to start going off and looking at DNS configuration settings when the problem has nothing to do with DNS. The problem is with OS deployment. Wake up, use your brain a little bit and say, well, that message has to be wrong. I mean, it just can't be related to some of the things that come up. We'll take a look at the ultimate example of that as we get deeper into the slides, because there's just no way that some of these errors should cause you to be distracted from troubleshooting the real problem. There is a tool that's really useful for first looking at these log messages, looking at these log files, and also for doing these error number translations. Trace32, it's part of the Config Manager toolkit. There is a newer version of that provided with Config Manager 2012 called CM Trace. We tend to use these fairly heavily to open up these log files and turn what's otherwise a kind of ugly file format into something that's a little easier to scan through. Both Config Manager and MDT write files out in this log format. This log format has attributes on it so that we can clearly mark which lines are informational, which lines are errors, which lines are warnings, so that they get highlighted appropriately in the tool. So that's probably the preferred way to go about it. There is some issues with the Trace32 version that's out there right now. It has issues with null characters in log files, so watch out for those. It has issues with log lines that are longer than 8K. Oh, when are you ever going to see a log that has an 8K error message in it? Surprisingly often. So watch out for those types of issues. Use the latest version to try to avoid those. There is a 64-bit version of it provided in Config Manager 2012 as well. So a lot of people will take a tool like this, Trace32 or CM Trace, and include it in their Windows PE boot images. So if they have an error, they don't even need to get into Windows PE, map a drive to a network share, copy the log off, and open it up. They just run Trace32 from within Windows PE. Look at the file right then and there. So let's look at Trace32 real quick. Actually, the new version, the old version, they all look the same. So I've actually got Config Manager 2012 installed. So as a result, I end up with the CM trace tool instead of trace32. When we say that we want to open a log file like the bdd.log from MDT, we get a fairly simple display where we can see the log text in the first column, the component, or the script name in this case, that wrote that entry, the date and time, and some of the other information isn't quite so useful. If there would have been any warnings in here, they would be highlighted. So as we can go through here, we could probably figure out from looking at this that this was a successful task sequence, that there weren't any issues reported. Now if we were to look at a different log, like the SMSTS log, again, this one's pretty clean, nothing too exciting, but there are some errors in here. Well, this log file goes with that same bdd.log that we were looking at. Even though there are errors flagged here, they aren't really errors. They're just normal instances as the task sequence is starting up. So we would learn over time that, yeah, we can ignore those. What we really care about would be any errors that occurred later in the process. But we can look at this tool and we can use this tool to figure out, well, what exactly is going on during the deployment process. There's one other capability to look at real quick here. There is an error lookup option. And if we type in an error code there, it'll tell us what Windows thinks that error code means. So a lot of these are numbers that people are used to. Like, you know that an error 5 means access denied. And if you were to look at that from the longer error number, that usually turns into an 80070005. And if we look that up, we get the same message, access is denied. But the most common error that we end up seeing is 80004005. What do you think this one means? Error 5's access denied. This is 80004005. Has nothing to do with security. So this becomes one of those areas where people get distracted by looking at this and saying, well, it's got a 5 at the end of it, it must be a security problem. No. This one means unspecified error. Useless. Basically, it's an error that says an error occurred. So that's the way the task sequencer usually ends. It usually ends with this 80004005 to say an error occurred. Okay, that's not useful. Now we had to go into the log file and figure out what exactly happened. So, getting to the root cause is the real key. Where do I look? Well, you can never have too many log files, so if there's ever any doubt, grab every one you can possibly find, zip them all up, and either go through them yourself or try to find someone who can go through them for you. Find the error message toward the end of the log and work your way backwards. Looking at errors that happen at the top of the log file in a file that's 10,000 lines long probably means that the error on line number 10 doesn't really matter and isn't related to the error on line 10,000. Focus on the bottom of the file. The messages themselves might not be specific enough to tell you what's going on. You may need to branch off into other log files to deal with, to find the additional details that are there. So then we get into each of the different tools. Each of the different tools creates its own log file. That's a lot of log files. Knowing which one to look for, knowing which one to look in for each of the different scenarios is key. And that's kind of where I spent a whole lot of this session in the past. Of course, typically I would do this in a 75-minute session or a 90-minute session, and we'd spend probably a third to a half of the session just going through log files, lists of log files. Log file smsts.log does this, bdd.log does this, loadstate.log, wpe init.log, all these different log files. Let me save you the trouble. Let's boil it down to the critical ones, the ones that you will always start with. There will be reasons that you want to dig into the other ones, but we'll worry about that later. So rather than going through all 20-something of the files that I've gone through in the past, I posted a blog entry while I was sitting in the row over here during the previous session with a document attached to it that says, here are all 20 of those log files. Here's why you would ever want to look at them. Here's what they might be able to tell you. So basically trying to take some of the stuff that I went through in PowerPoint slides in the past and turn it into a document. Instead, let's focus on the main three. Setup.act.log is the log that gets created by Windows when it's installing. Doesn't matter how it's installing, doesn't matter where it gets installed from, it will eventually create this setup.act.log file. If you're installing Windows using setup.exe, it might create more than one of these. If you're installing it using ImageX, it might create one, it might create two. Doesn't matter. Grab them both. Grab them all. Any place you can find setup.act.log, it may be useful in the troubleshooting process. SMSTS.log is created by the task sequencing engine. Both Config Manager and MDT run the same engine. The Config Manager team wrote it. MDT integrated that as part of the light touch deployment process. Not a big surprise. It writes out the same log file regardless of whether it's running in Config Manager or somewhere else. That doesn't mean it's in the same place, so finding it might be a challenge, but it will be the same log file. The other thing to watch out for, SMSTS.log will only grow so large before the task sequencer renames it and creates a new one. So don't just grab SMSTS.log, grab anything that starts with SMSTS and ends with .log, because it'll create ones with a date timestamp in the file name. That would be the previous generation that would show earlier entries in the logging, in the deployment process. In the case of light touch deployments, we tell the task sequencing engine to create a big SMSTS.log. So don't wrap, don't rename it, don't create a new one until it's like 10 meg in size, because we want all the entries to be in one file because that makes it easier to troubleshoot. In Config Manager, though, the default size is like 1 meg, and then it rolls over. The challenge is it only keeps one previous generation by default. So it may, as part of the error recovery process, roll over multiple times and cause you to lose the original error message. So there are some tricks out there in various blog entries of how to make that log bigger so that it doesn't wrap around nearly as often, so that you don't have to try to reconstruct the problem to figure out what happened because the log's no longer around. But search the system for it wherever it happens to be, grab the copies of it, grab the other older generations of it. You may need them as part of the troubleshooting process. The third one then is the BDD.log. It's created by all the MDT scripts. They all write all the entries to that one log file. Each script also writes its own log file, but it doesn't write anything different to its own log than it does to BDD.log. Every entry gets written to both files. So BDD.log has everything in it that you would need. You don't need the other ones if you don't really want. Sometimes it's easier to look at one of the individual script logs just because you don't have as much to deal with, but BDD.log is enough to construct the whole process, to look through all of the entries from all of the scripts. So that would be the bare minimum. If you say, I'm having a problem, and someone replies back, can you send me the logs? Those would be the ones they would expect to see. If they dig through those and say, oh, well, this one points to an issue that maybe you also need to find the log from loadstate.exe. Well, there's always the chance that you need to find another log to add into the process, but start with those three and always branch out from there. So the doc I posted on the blog goes through those three and tells you where they might reside, all the different locations where they bounce around to, and also lists the 17 other log files that you might need to branch into as you're troubleshooting. The next problem then is, well, how do you get to these logs? It's easy enough if you are in the full operating system because, well, you can just open up a command prompt and you can scan the whole disk looking for these log files. But what if the failure happens in Windows PE? There's no OS there. You just end up with an error dialog on the screen with a countdown that says after the 15 minutes the machine's automatically going to reboot. After it reboots, those log files may disappear. So you don't necessarily have a lot of time to get those log files unless you open a command prompt. Both Config Manager and MDT have the same functionality where if you press the F8 key inside of Windows PE, it opens a command prompt. That command prompt not only lets you find the log files, but it also prevents the system from automatically rebooting. So even after it goes through that 15-minute countdown saying an error has occurred, I'm going to restart after 15 minutes, well, the dialog will go away, but it'll sit there at that command prompt and won't reboot until you exit that command prompt. So even if you know, well, I don't have time to troubleshoot it right now, start a command prompt just to keep it from going away. Keep it in that state until you have time to actually look at it. There are some scenarios, though, where the task sequencer, MDT, config manager, they've kind of gone away and handed control over to the Windows setup process. In those cases, the F8 key won't work. In those cases, you need to press Shift F10, but the result's going to be the same. When you hit Shift F10, it's going to pop open a command prompt, and you can do additional troubleshooting from there. So we'll see some examples as we're going through here where Shift F10 is necessary to get to the logs. So now let's shift and talk about common issues with Windows. And it's not like we can come up with, here are the 5 most interesting and common problems that are going to happen as you're deploying Windows. All we can really do is say, here are some examples, and here's how to troubleshoot those examples. So where do we look to solve a problem that's similar to this? So in this case, a bad computer name. Well, you're going to get a failure during the deployment process. It's going to say that there was a problem in the unattend.xml. It's going to say that it was in a particular pass, but it's not going to tell you any more details. How do you figure out which setting actually had the problem? So, yeah, okay, in this case, the problem can be caused by putting in a computer name that's longer than 15 characters. So, lesson learned, don't do that. That's not the important part, though. The important part is being able to figure out, where do I look to figure out what the real error was? So let me switch over to a sample machine here, and let's look at a machine that has that exact error on the screen. So in this case, you can see behind it, I've deployed Windows 8, but the same thing would happen with Windows 7. It's going through the specialization process, and as part of that, it read in the unattend.xml to see how should Windows be configured. And while it was doing that, it came back with an error that says Windows could not parse or process the answer file. The answer file is invalid. Okay, we know it's invalid. We don't know why it's invalid. All we know is which pass was invalid. Not too surprising, it was the specialized pass, because that's what Windows is doing right now, is specializing the OS. So if we hit F8, nothing happens. Not a surprise, because the task sequencer is handed over control to the Windows setup process. So in this case, our only option is Shift F10, and that opens up a command prompt. Now we need to find the log. Normally, Windows writes log files to the Windows Panther folder, and the files that we're interested in are setupact.log and in some instances setup_error.log. So setup_act.log is the main log file that Windows writes an excessive amount of information to during the deployment process. Setup_error.log is where it writes only the error messages. This gets a little interesting too, because you would look at that and say, well, okay, setup_act.log is about 61K, setup_error.log is 0, so there must not be anything in setup_error.log. Well, let's try that. Let's try Notepad setup_error.log. That doesn't look like 0. Looks like there's something still there. It looks like there's data in this file. Well, it's showing that it's 0 because Windows has written entries to the log file, but it hasn't yet closed the log file. So the file's still open, and Windows won't show the actual size of the file until it's been closed. So don't assume that a 0-byte file is actually an empty file. It just means that, well, it hasn't written enough to flush the buffer. So in this case, we can see the actual error message here, where it says that the Microsoft Windows Shell Setup component has a setting in it called computer name, and that computer name value, if we scroll all the way back over there, is invalid. Okay, so we know now that that's the particular setting that was invalid. Well, in some cases, you can figure that out directly from this setup_error.log, but in other cases, that might not be, you might see the error, but you might not see the context around it to see what actually happened. So you may need to go back to the setup_act.log. In this case, it's not really necessary because that was clear enough, but it's easy enough to just search for comma space error, and that'll take us to the first line that would have been logged to that setup_error.log, and we can see the same information here. So easy enough to tell that, okay, the value in that particular setting is not valid. It's also good to know that the unattend.xml that's being processed by Windows is in the same folder. It's right here, unattend.xml. So we can actually open it up here and see why is it not valid. So if we search for computer name, we can see here that that value is much longer than 15 characters. So I cheated in MDT. I told it to use the serial number of the machine as the computer name. If you've ever looked at the serial number in a Hyper-V virtual machine, it's longer than 15 characters. It doesn't work as a computer name. So it stuck it in there. It's not valid. Windows complained about it. Simple enough problem, but the same thing can happen with any of the other entries in this unattend.xml file. And you'll get the same exact pop-up. You'll get a pop-up that says the unattend.xml for past specialize wasn't valid, and it won't tell you what wasn't valid. So you have to dig into the log files to figure out what wasn't valid. So that's a common scenario where you see an error like this on the screen and you have to dig in and figure out what's going on. Another common problem that we ran into that we saw people report on was they're doing a deployment. They've created a task sequence in MDT. They're installing an operating system. They've specified the image that they want to deploy in the task sequence. And it pops up a dialog on the screen that says there are no images available, which makes no sense. We just said there's an image that has, there's a WIM there that has our image in it. Why is it telling us that there are none available? Well, the setup program that Windows uses to install does some filtering. It says, okay, I see the WIM file. The WIM file has 8 images in it. I see that you specified an image index. So now I'm going to filter from 8 images down to the one that matches that image index. Let's say I specified index 1. It's then going to keep going and say, I'm going to apply another filter based on the product key that was in the unattend.xml and filter out any images that don't match that product key. Well, if you put in the wrong product key, how many are going to match the wrong product key? 0. So you get an error on the screen that says no images were available. So in this case, no images are available really means you put in the wrong product key. Well, how the heck are you ever going to figure that out? You'd have to dig into the log files to see in that same setup act.log that it found the product key, it saw that that was for, say, professional, but when you were actually deploying, you were deploying enterprise. Doesn't match, filters it out. So that happened fairly often in MDT 2010. You'll never see this with MDT 2012 Update 1. You'll never see this in Config Manager when you're deploying an OS image package. Why not? They don't run setup anymore. In both of those cases, the image, the WIM, is applied directly to the hard disk. And when the operating system boots up, it reads the unattend, it tries to install the product key that was specified, it fails to install the product key, it logs an error, and it keeps on going. So it doesn't stop. All you end up with is an operating system that doesn't have a product key installed, so it won't be able to activate unless it's a volume license version. It can find KMS, and then everything works okay. But for retail versions or Mac keys, you're going to find out that it just didn't activate at all, and you'll start to get nagged to say that Windows hasn't been activated. Do you want to activate it now? So we've changed the process to try to avoid this type of thing because it's just one of those deceiving scenarios where no images available just doesn't really clearly indicate what the real problem is. Another common problem that we saw initially when Windows Vista and Windows 7 first came out is people would try to take their old processes and make them work with Windows Vista or Windows 7. So they had a Windows XP deployment process where they would put an unattend.txt on a USB key and they'd do a deployment and they'd leave out the computer name, but they'd specify they wanted to join the domain, and Windows XP would prompt for the computer name, they'd type it in, it would join the domain, everything would be happy. But if you ever tried to do that with Windows 7, it wouldn't work because it would join the domain and then it would set the computer name. So it would break the domain join. So you would end up with the right computer name. You would end up with the old computer name joined into AD. You'd try to log on with a domain account and it would give you a message back saying that the trust relationship between the computer and the domain's been broken. It's okay, so you then have to rejoin the domain. So we ran into that early with Windows Vista. We just changed the process so that that never happened. We made sure that with MDT or with Config Manager, we would always put the right computer name and the domain join information inside of the unattend.xml, so they were both processed at the same time, so it would join with the right computer name. We thought, okay, with the next version of Windows, they'll probably fix that. That they'll make sure that it can work the same way as old XP did. But instead, they just took out the prompt for computer name altogether. Let's solve the problem by never asking for a new computer name so that the only way it will join the domain is using the randomly generated one or the one that was already in the unattend.xml. So, okay, they fixed it, but not quite the way we expected. But regardless, it's just one of those scenarios that it's like that by design. Just make sure that you don't try to do anything like that and you should be okay. A more common issue that we run into is this one. So we're trying to do a domain join and it doesn't work. And we had to figure out why. So in this case, let's just look at another machine here that shows that exact error message. So if you've done a light touch deployment with MDT, we try to join the computer into the domain by specifying the details for the domain join in the unattend.xml. But it's possible that that initial domain join would fail if you were using static IP addresses, because when the computer first boots up, it's going to read the unattend.xml, try to join the domain. Well, we haven't put the static IP in place yet, so the domain join is going to fail. That's okay. We keep going. We put the static IP on. We notice the domain failed, and we try again. So there's a script in the task sequence that says retry the domain join. But, okay, it tries the join again, sees that it fails, reboots. Tries the domain join, it fails, reboots. Does that 4 times before it finally throws up an error saying, I give up. We've tried to join the domain once through the unattend.xml. We've tried to do it 4 more times with this script. It still didn't work. It's a safe bet that it's never going to work. So logs an error and keeps on going. In this case, ZTI domain join, the script, has attempted to join the domain too many times, count equal 4. So it's a non-fatal error, but it was something that we thought you should know about, so it was logged as a warning in the log file, and it's something that you'll need to take some action on. So let's go ahead and click Finish. We'll see the shell load up, and then we can go looking at the log file related to that to figure out what happened. So again, this is one of those things that's exactly the same between Windows 7 and Windows 8. In this case, I'm using Windows 8, but it doesn't really change anything. We still need to go to C, Windows, Debug, and we'll find a file called netsetup.log, and this is where each domain join attempt gets logged. So we can see initially the computer came up with a random name. Let's just scroll down to the end, following our own advice of looking at the last attempt as being the most interesting. So we can see here that it attempted to join using the local administrator account with a blank OU. That one doesn't look too bad. Till we get down a little bit further. Now it's starting to complain about an error 534. And finally it says the final status was 534. Well, what is error 534? Well, it's in hex, so there's another one of those good skills. How do you convert a hex value into a non-hex value? Well, fortunately, calc is built in. We tell it, 534 hex. In decimal, 1332. Net help message 1332. No mapping between account names and security IDs was done. Well, that doesn't make a whole lot of sense. So even with this, we'll end up with situations where we look at this and it just doesn't look right. So all right, well, let's look at the previous attempt. Maybe the previous one was a little bit more interesting. Well, in this case, it tried something different. It said CN equals computers, DC equals MDT, and DC equals local. And later on, it came back with a message saying the specified path is not an OU. So this almost requires looking inside of the MDT script to figure out why did it do this? Because first it tried to join the domain using an OU, in this case CN equals computers. Then it tried it without an OU, basically to update an existing computer object. So it made 2 attempts for each of those 4 tries. So really it didn't fail 4 times, it really failed 8 times. If we kept going back through here, we would see that there were 9 actual attempts to join the domain. 1 through the unattend and then 8 more through the script. But this is the real cause. Specified path is not an OU. It's not valid to put in the unattend.xml CN equals computers, because it's not an OU, it's a container. Okay, simple example there, don't do that. So in this case, the only way I got that to happen was I forced cn equal computers into my unattend.xml by just putting a rule into MDT that says cn equals computers. So we know that we shouldn't specify cn equal computers. And I had to go out of my way to make that happen with light touch. But the interesting thing is, if you go into Config Manager and you edit a task sequence and you find the step in the Config Manager task sequence to join a domain, which is the apply network settings step, which is right here. We can specify a domain OU. We can browse to the domain. We can choose computers, and it will happily put that same value in there. But yet, if I were to click apply and then go through the deployment, I'm going to have the same problem with Config Manager. It's going to try to join the domain with that container. It's going to log an error saying it's a container, it's not an OU, and you're going to end up with a machine that's in a work group. How is that worse with Config Manager? There's one other little gotcha here. In a default task sequence, in the apply Windows settings step, there is an option to randomly generate local administrator passwords. So what happens if you deploy an operating system and it fails to join the domain and you have it set to generate a random administrator password? You better hope you have a copy of Dart or some other tool to try to break into the local administrator account so you can log into the machine so that you can join it to the domain and continue on. So another thing I would generally change is change it from randomly generate to enable the account and then type in a password that you know, and only you know for security reasons, so that if this domain join were to fail, you can recover from this situation. Otherwise, you have a perfectly functioning Windows installation that all you can do is throw it away and deploy it again. Another common issue isn't fatal, but is by design. You can tell Windows to join the domain in a particular OU. It'll join the domain just fine, but it'll ignore the OU part. So the computer will end up in the original OU where the existing computer object was. It's been like that for an eternity, but it's really irritating. Let's say you have all of your group policies targeting your Windows XP machines. Been like that for as long as you've been running XP. Now you're deploying Windows 7. You've created a new set of group policies for Windows 7. Your Windows XP GPOs are tied to your Windows XP OUs. Your Windows 7 GPOs are tied to the Windows 7 OUs. You expect this to work to move the computer objects, because you're going to continue to use the same computer name, from the old OU to the new OU. Doesn't happen. It's going to just update the password of the existing computer object, leave it in exactly the same place, and it's going to continue to get the Windows XP policies. You better have a plan B, because this will never work. You can run a script to move the object. You can try to set up some type of web service to do it. You could use Orchestrator to do it. There's various other ways to move that computer object into the right OU, but the deployment process isn't going to do it for you by design. You can also run into issues where the computer just crashes, and you have to figure out why it crashed. This is hard. I mean, trying to even see what the crash was is hard enough, because by default, with Windows 7 and above, the operating system immediately reboots after a crash. So unless your eyes are really good, you may not even see what the stop error was before the machine reboots. You can turn that off. You can turn off the auto restart by setting a registry entry to say, no, I don't want to do that. I want to stop on the stop screen so that I can actually see it. And then I can probably figure out from there what caused the problem. There are really only two stop errors that we generally see that are something that we should do something about. One of them is a stop 7B, which means We're missing a mass storage driver. We're deploying to a particular piece of hardware and we don't have the storage driver for the hard disk that the OS is running from. We need to fix that. We need to add the necessary mass storage driver and deploy again. Easy enough. The second one that is probably our fault is a status C0000359. That one means that Windows tried to load a driver, typically a mass storage driver, but it could be any type of driver, and it got an exception during the driver load process that indicated that the driver was for the wrong platform. So it tried on an x64 OS to load an x86 system file, sys file, or the other way around. It was on an x86 OS and it tried to load an x64 driver. Doesn't work, so you get a blue screen with the status C0000359. That's one of those issues that we think we've dealt with reasonably well in MDT for light touch deployments, because when we import drivers now, we'll detect the real platform for the drivers and automatically uncheck the wrong one. So if we read an INF and it says this driver supports x86 and x64, but we can't find any evidence of the x64 files, well, then this must not really be an x64 driver. It's just a lazy vendor that's using the same INF file for x64 and x86 versions of their driver. That's great for light touch. Config Manager doesn't do that though. So if you're building driver packages in Config Manager, you may need to manually separate out the x86 and x64 drivers so that you never accidentally inject the wrong one into a deployed operating system. Because if you do, it'll blue screen. There are other errors that you might run into, but they're kind of rare. Like, you can see a stop EB, especially if you're dealing with 4K disks. If you happen to be in the previous session that was in this room where Ben Armstrong was talking about 4K disks. Most machines shipping today use 4K disks with 512 byte emulation so that everything continues to work okay. But if you're deploying Windows XP to one of these, and you tell Windows XP to extend the OEM partition to the full size of the disk, XP basically obliterates the volume as part of that process, and it gets a stop EB saying unmountable boot volume. It's toast at that point. All you can do is wipe the machine clean and start over. In that case, the fix is actually fairly simple. You can go in and say to not extend the OEM partition. There's an entry in the MDT unattend.txt or sysprep.inf. If you're deploying XP that specifies to do that, you can unset that and everything will work okay. Of course, Windows XP doesn't actually support 4K disks or 512E disks, so you're kind of on shaky grounds anyway. That's just one of the problems that you're going to run into with that type of a hardware configuration. You can also run into issues in Windows PE. Fortunately, in Windows PE, we have a shorter list of issues. Most of the time, the issues that we deal with in Windows PE are related to networking. So we have to be able to figure out what does a particular situation look like so that we know what causes it. If we were to switch over and look at a couple of machines, so I have a computer here. If I type ipconfig in and get this, what does that mean? Nothing there, no response, no entries at all from ipconfig means there's no network driver installed. Well, I have to assume that the machine has a NIC. I just don't have a driver for it. So in order to fix this, I would have to identify what driver was needed, which I can do through the WPE and init.log file, add that into my Windows PE boot image, and then try again. So that one's not too bad. Then we run into additional ones that are just kind of subtle variations on the same theme. And trying to figure out the difference between those becomes one of those key skills. In this case, what does this one mean? I type in ipconfig and I see that the machine has a 169.254 IP address. It's a locally administered address. It probably tried to pick up an IP address via DHCP. It didn't get one. Well, I was refreshing this from an existing operating system. My existing operating system could talk to the network. Why is Windows PE not able to get a DHCP lease? This is where you get into weird switch configuration issues. Works great in the full operating system, but Windows PE isn't as forgiving and times out waiting for a DHCP lease while the switch ports and the NICs are negotiating the full duplex 100 megabit connection that you would normally want them to get. Simple fix in this case: reconfigure your Cisco switches to specify spanning tree port fast, because then they'll negotiate faster. As a result, they'll be able to get a DHCP lease and everything will be happy. Okay, well, why don't people see this all the time? We added logic into MDT so that when we see a NIC with a 169 IP address, we automatically do an ipconfig renew in a loop multiple times until it works. So it doesn't matter if the negotiation takes 60 seconds, if it takes 90 seconds, whatever, we will be able to get an IP address and continue on. In this case, I cheated and I just put this machine on a network that didn't have any DHCP server on it. So in this case, it was never going to work, but it would continue to retry that as part of the MDT initialization process. While we're here, though, let's look at another log file. In Windows System 32, there's a file called wpe-init.log. This is the log that Windows PE creates as part of its initialization process. In most cases, we don't care so much about what's in here. What we care about are the timing pieces. So we can see in this case, actually a few different entries. We can see that it's installed a driver for a particular NIC, so it prints out the plug-and-play ID and the INF that was for that particular driver. It says that it spent 6.4 seconds installing that network driver, and then it waited 90 seconds trying to initialize the network before it gave up and allowed the execution to continue. That can add quite a bit of time to the deployment process as it's going through and doing that. But if you were just having general questions about, well, what driver is it loading? Why is it taking so long when I see the initial Windows PE background screen before it starts doing something? This log would be able to tell you for each phase in that initialization process, how long did it take. Eventually, it would get to synchronous commands and it would start running those. And at that point, it really just, those might be an MDT task sequence, so those are expected to take a while, but everything getting up to that point is just initialization work. So if you have slow startups, looking at this log file can be useful. The other common issue in Windows PE, which happens way too often, is people say, okay, I've downloaded the new version of MDT. I've installed it. I've created the boot images. I've added it to WDS. I've tried to PXE boot a new VM, and it's not working. Windows PE starts up, the MDT scripts look like they start to run, and then this machine immediately reboots. What's going on? Well, one of two things generally has happened. Either they didn't actually update WDS with the latest boot image, and now they're trying to use an old MDT 2010 boot image with MDT 2012, which doesn't work so well. Or they created a VM with 512 meg of RAM, which happens to be the default. Windows PE doesn't boot so well on a 512 meg machine. The latest versions of Windows PE need about 700 meg to run okay, because Windows PE is not running with the page file. Page files generally get in the way of OS deployment processes, so it will reboot without actually telling you anything, because the scripting engine might fail or WMI might fail. Just random components fail to install and the machine just reboots. Another challenge that we've run into, everything's working fine. We've deployed a new operating system. It boots up for the first time. We expect the task sequence to continue for MDT to install apps. Never happens. What's going on? The strange thing is, over and over again, we're finding out that the image wasn't sysprepped. Why wasn't it sysprepped? Aren't you using MDT to sysprep and capture your operating system? Oh no, I did that manually. No, you didn't do that manually because the operating system isn't sysprepped, so when it boots up, it doesn't know to even read the unattend.xml, which contains the commands to execute on first logon. So in a lot of cases, they will do something manually to create their image. So they use MDT to install the base of it. Then they do some manual stuff. Maybe they configure the shell or install some apps that they haven't figured out how to automate. And then maybe they run sysprep manually. Well, it doesn't work. It might come up with an error message because their unattend.xml wasn't right. It might just fail for whatever reason. They just ignore the error and boot into Windows PE and capture a WIM file anyway. Okay, looks like it worked okay when you deploy it, but it's not a good idea. You need to make sure that the machine was successfully sysprepped before you capture an image. We've also ran into challenges where one task sequence failure can cause issues with the next task sequence deployment. We've tried to address that in MDT 2012 and MDT 2012 Update 1 by setting flags to indicate when things are restarting cleanly and when things are failing. And as a result, you may see a dialog like this one that says, "We found a dirty environment." The task sequence was running along and something happened to it. Now you're booted back into Windows PE or even back into the full OS, and we're trying to resume it, but we don't know how we got here. We don't know what caused the machine to reboot to get us into this point. Did the OS install fail? Did the task sequence get killed when an application install rebooted out from under the machine? Doesn't really matter what happened. Something happened to get in the way of the successful normal execution of the task sequence. We can detect that and clean it off. The most common scenario related to this was that, okay, I'm running a deployment. It got so far, okay, it's gotten past what I wanted to see. I'll just hold the power button and turn it off, and then try to do another deployment to the same machine. But the previous set of files on the hard drive would interfere. So we added this logic into there to detect that. It would display the same message in that case. We also saw errors where people would try to do deployments and get an error back saying that unable to find setup needed to install the image. Well, MDT always used setup to do the deployment. In this case, it couldn't find setup, so it generates the error. This was most common when they were creating media, because they would have the full source files in their deployment chair, but when they created the media, they wouldn't have the full source files, and as a result, it wouldn't be able to find setup and it would fail. In MDT 2012 Update 1, you'll never see this error, unless, well, no, you'll never see this error. Because we don't use setup.exe to deploy the OS anymore, we always use ImageX. So, fairly easy to work around this one now. Task sequence failures, are always going to be a challenge, and figuring out why they happened is always going to be a challenge, because it could be just about anything. There could be invalid command lines, there could be something that returned an unexpected return code. Who knows what it is? We'll have to go digging through logs to figure that one out. We'll have to find the smsts.log to see what the real reason is. Let me look at one other machine here. Which one did I put that one in? Yeah, so here we have an error that said we got an 80004005. Why did that happen? So I can hit F8. I happen to know that the log file at this point in time is in the temp folder, smsts log. If I open smsts.log, scroll down, there we can see the final message to say that an error occurred. If we keep scrolling up from there, we can see a message here that says the printer is out of paper. Yeah, somehow I don't think the printer being out of paper caused my OS deployment to fail. What really happened was I had a very simple step in this task sequence. And that simple step said, exit with return code 28. Well, what is return code 28? If you were to go to a command prompt and type net help message 28, printer is out of paper. So that's what it translates it as. And don't pay so much attention to the messages. Pay attention to the numbers. In this case, error 28 happens to be a valid return code that comes from USMT. Has nothing to do with being out of paper. It also returns back, I think, an error 27. Drive cannot find the sector requested. No, that's not what it's really complaining about. It also returns error 72. Specified printer or disk device has been paused. No, that's not what it's trying to tell you. So you get these false error messages. You just need to learn to ignore them. Another common error, if you try to generate a catalog on a 64-bit OS for an x86 operating system, it'll fail. All right, that's because the Windows AIK and Windows ADK don't support doing that. We changed the error message in MDT 2012 to tell you that this error is happening because you're trying to generate a catalog for an x86 OS on an x64 OS. So now at least you'll know why it's happening before it just came back with a random garbage error. So we tried to clean that one up. But you might need to generate the catalog from an x86 OS just so you can edit the unattend.xml. But for the most part, you don't edit unattend.xmls that often to put in your own custom settings. So you may not ever run into this if you never want to use the Windows System Image Manager to edit the unattend. Config Manager, now we're running out of time, so we'll skip through this one fairly quickly. It's the same basic idea. We run into task sequence failures. We get the 80004005. We need to look at the smsts.log. The one advantage that you get with Config Manager is it captures the last 1,000 characters of output into the smsts.log so that you don't have to look into other log files to see what output that command might have generated. So that one's good. You can also run into issues where Windows ends up deploying just fine, but instead of running from C Windows, it deploys to D Windows. That will happen if you tell Config Manager to use an install.wim as an OS image package. Don't do that. You have to recapture it using an OS setup package to build your image. Sysprep would capture it and then deploy it as an OS image package. You can also run into hash mismatch errors where you do a task sequence deployment, it gets to a particular step, it wants to download a package, it compares the hash against what's on the server after it does the download, says they don't match, task sequence fails. Simple enough. You can update the distribution points to push out a new version of this. Well, let's say you push this task sequence out to 200 machines. And the particular package that has a hash problem is the operating system image. Guess what's going to happen? You're going to have 200 machines in Windows PE with an error message on them and no way to recover them except for manually trying to clean up the mess. So definitely try each task sequence on a small number of machines before you push it out to a large number of machines to make sure you're not going to run into this with large-scale deployments. Package is not available. In this case, at least you get an error up front that says, before I've even started the task sequence, one of the packages wasn't available on a local DP. That one's easy enough to fix. In Config Manager 2007, I had published a PowerShell script to check all of the packages referenced by all the task sequences, and for any that were missing from any DPs, push them out. So kind of clean things up, get everything out to all the necessary DPs. In Config Manager 2012, they've turned that into a wizard. So in Config Manager 2012, there's a distribute content wizard. Right-click on a task sequence, say you want to distribute content. It'll show you the list of all the packages referenced by that task sequence. Then say, well, which distribution points do you want to push them to? And it'll take care of doing the rest. So much easier with Config Manager 2012. Pixie Boot, we could spend days on this one. Basically, there are some key blog postings out there that explain how to systematically go through Pixie troubleshooting. We'll skip over that one for now, but that one you can spend quite a bit of time trying to figure that one out. The main thing would be read through the log files, pay attention to the details of what the different error messages actually mean that you may see on the client side. And that's it, because I'm out of time. We've gone about 5 minutes over, as usual. These 1-hour sessions are just killing me. I really need 75 minutes. Oh, vouchers too. So for anyone who's managed to stay around this long, we have some gifts, which we'll give out. I can't come up with enough questions to try to stump these people, but let's just try it. Who can tell me what one of the most important log files is? smsts.log. What's another good question? Let's just go down the list. What's the second log file? bde.log. What's the third one? What was that? Setuperror.log. That's close enough. I usually prefer setupact.log. Now we need to get a little tougher because we're running out of cards and we have to make people actually try for this one. I don't even know the answer to that one. Has to be something that I would be able to verify. What's the name of the log file that's created by MDT when it runs scanstate.exe? If you know that one, you have memorized it because we didn't talk about it here. Nope. Did I stump everyone already? Scanstate.log is right for config manager, but in the MDT case, it creates usmtcapture.log because we like to make things a little different. Troubleshooting. What's the status error that you'll get when you have the wrong platform driver and you can't get two of these? Close. That's for the mass storage driver issue. Wrong platform driver. Starts with a C. It's very close. That's close enough. C0000359. Two more. I'm struggling for questions. What's the name of the kit that contains trace32.exe? SMS Toolkit, close enough. I think it's now called the Config Manager Toolkit, but same idea. And last question. What does error 27 mean? That's 28. That would be too easy. What was 27? What was that? You already have one. I think there was an answer back farther. Yes, it was related to disk sectors. And with that, we're done. We've held you enough. It's party time. Please fill out your evals. Thanks for coming.